Hi, welcome back. Now I've taken over from Jay at this point. I'm going to help you design the shaders for your character here. So you finished off in the last part in ZBrush where you generated all the maps, your color maps, your displacement, your normal maps and whatnot. Now the reason I've taken over here is because I did the final image that you might have seen on the site. Or at least one very similar to this, so I thought I'd run you down of the design of the shaders in Maya that I used for this and how to apply the displacement and the normal maps you've created. So I'm going to start with this scene here, which is just a basic import of our creature model, nothing really fancy. I've got the default lighting in Maya turned on, which is on by default. Under render options you'll see this enable default light. It's generally on, but just check that, and I just want to give you an example of what this looks like if we just hit render, just for comparative purposes later on really. So as you can see, if we try and apply textures and everything to this right now, you're never going to get something that looks good. So in my experience, before you start to design your shaders, it's always better to take a look at your general lighting conditions, set up some form of environment. Now the environment we see in this image is actually a true 3D environment. It was done using our Create Realistic Environments tutorial, which you can find on the site, but for the purposes of this I'm just going to set up a simple sphere with some form of environment on, because in order for us to catch a light here and catch reflections, we're going to need some form of scene in here, or albeit a real one or a fake one, in order for that to work. So before we start to get on with the materials, I just want to create some very basic light and get this to look a little better. Okay, so I'm going to make this really simple. We've got a ton of lighting tutorials on the site if you want more information or if you want to get more creative, but just for this I'm just going to set up something that's a little better than Maya's default light. So let's come here and select our directional light. Now I'm going to scale that up because the creature, and I will say this, is of quite a large scale obviously. So let's just rotate our light about and get it at a decent-ish angle. Now obviously with a directional light it's all about the angle. It doesn't really matter where you move it in the scene, it's just about where it's pointing. But I just want to get mine to the point where I can see it in the shot, and because if I tweak it later it's a good indicator. And let's give this a try. So what we're looking is just very basic illumination. I'm going to make sure that shadows are turned on this light. So I believe in Maya 2014 ray trace shadows are on by default, and we'll just take a quick look. Okay, so we've got a very basic level of light in here. I'm also going to change the color of this because I want to match more of a sky. So what I'm going to do, rather than just going up to the light and doing a simple color, I'm actually going to add a mental ray node. So let's go to mental ray lights, and I'm going to add a, where have we gone, black body. This will allow me to define a temperature in Kelvin, and I'll just bring up a temperature chart for you so you can see what I'm on about. Okay, and I have one here. So these are the degrees in Kelvin. So let's say I wanted a very sort of orangey yellow image. If I set the temperature to around, let's say 3000, this will be sun at sunrise or sunset. And because I've used this black body, I can actually now set this to 3000. And you'll see here that our render will go slightly orangey. Or in this case hugely orangey, because everything's just kind of hitting this grey neutral surface. So again, if we go back to our temperature chart, we could look, if we want bright daylight, it's around 5500. Whoops. And now I'll hit this and it will be very blue. Or in this case just slightly off blue. If I turn that up a little bit, you should start to see more blue coming in there. But you can always just simply, there you go, so we got this purplish blue, sort of more natural daylight color to this. Now I prefer to use the black body instead of just picking a color. I find it more accurate, it gives a more overall pleasing result. And you can always just search Google for Kelvin temperature scale and you'll find many of these. So I don't want to spend too long on the lighting. I just, as I said, wanted to get us to a point where we can actually start to apply a texture and see what it would actually look like as part of a finalized scene. So the next thing I'm going to do is just add an IBL, an image based lighting. So up here under indirect lighting, just hit create, and this will give you a IBL node, which you can see here. And now we need to give it a HDR image, a high dynamic range image. So I've got one here. Again, if you do a search online, you'll see that you'll find many of these. This one came from hdrmaps.com. I won't be giving it out with a tutorial because it's in their copyright, but you can go there and download it from their website for free. So now we do another render with the IBL node. Okay, and it's important to recognize at this point that I won't be using this IBL node in the final background. This is simply here just to provide some reflections on this character, and I can give you an example of that by simply changing the material on this to some sort of mirrored material, sort of chrome. So I'm going to assign a mirror material to it, and I'll use the mirror material X, and under its presets we'll just change that to chrome, and you'll see that our reflection actually works. Okay, so that just confirms for us that our IBL node is providing a reflection. Now you could just use a simple environment sphere for this, but I prefer to use the IBL node in a lot of circumstances, this being one of them. If I flick the alpha channel, you'll see that when we take this out for final compositing, that the IBL node is, image is not actually there. It's purely for the reflections. Or refractions if we have any, which we won't in this, but just if you need that. Okay, so now we've got some form of basic light going on. We need to set up some form of global illumination, because if we look under here, it's quite dark under the chin here, perhaps but not the best place to see it. There we go. So we need light to bounce around the scene, so for that we'll use Final Gather. I'll just flick Final Gather on. Now this accuracy is way too high, especially for testing purposes, and again with point density. Now if you're doing an animation across many frames, you might need to raise this accuracy up a bit, but for a still shot I find these are pretty good settings to use. I'm not going to go through them in depth. As I said, plenty of lighting tutorials on the scene, on the site. And I don't want this one to turn into sort of an 8-hour epic. I just simply want to show you quite a simple lighting setup. So let's put our Lambert back on and see how our bounce light is working for us. Okay, now I'm bouncing that blue light from the sky image, and I've got my light set to blue as well with our Kelvin black body node, and you can see now I'm getting bounce light under here. So before we were in complete darkness, and now we're starting to set slightly better conditions to apply our textures to. Now all we've got is one directional light and this IBL. Now if you wanted to, you could go into the IBL and have it actually light up the scene by getting it to emit light, which I probably won't bother with, but I'll just show you quickly in case you've never done it. So under the IBL shape node you'll see a light emission. You can turn this on to emit light. Now this is going to be far too high, so let's go down to 64 and 64. And when you do this, you're going to notice that this is going to take up quite a bit of render time. So normally I don't bother with it, but just to show you the effect it has. So as you can see, this is with the emit light function of the IBL, and this is without. So it does make quite a difference. You can also see that we now got two shadows. This is because the main body of light from our IBL is, and let me just work out why this is not showing. Okay. And I should actually be seeing the IBL node in the background here, but I'm not, which could be for several different reasons, but I think probably camera clipping planes. And as you can see, my far clip plane is only set to 100, so let's set that to 1000. Okay, and what I wanted to show you was the reason why we're getting these dual shadows is because the sunlight in the IBL will be up here somewhere, which you'll be able to see if I simply rotate it a little bit. There's the sun. So that kind of should show you that when we hit this emit light, this IBL actually does emit light. The other thing I want to do is just turn this off at infinite, and then I'll be able to scale it closer to approximate scene size. If it's on infinite, the scaling won't matter. You'll be able to scale it, but it won't have any effect. So let's get another render as such now. Okay, so one of the reasons I turned on this emit light, even though I don't use it so much, is because I want this IBL sun placement to kind of mirror up to where my directional light is in this scene. And this is a really quick way to see where the main light source from your IBL is coming from. So let's just rotate this kitty around to approximately where our light would be, and it should be, I reckon, around there. So I don't need this anymore, so I'm going to turn it off. I just generally use it to debug the placement of my image-based lighting, and you can turn it on. It will give you some nice results. It can add a massive amount of time to your render once you start cranking up the quality, and in this case we're simply not going to need it. So we've now got this sort of basic scene set up, and we can go ahead and start applying our textures. Now, with the way the UV maps were done for this, there's a really quick way to apply the textures for it. So if we just select here and bring up the Edit UVs UV texture editor, you can see in here that we've got the head, the feet, the body, okay, all on this one character. So if I want to assign a material to the head, I can just hit face mode here, select these, go here, assign a new material, and I'm going to be using Maya Material X throughout this particular portion of the tutorial. So let's just click one on there, and that's one for the head. Now let's go back and assign a different one for the body. So let's assign a new material, and once again Maya Material X, and back again and assign one. That was the legs, sorry, not the body. Now let's assign one for the body, and it's having a little hissy fit. There we go, thank you, and assign new material. So now we have a Maya Material X assigned to the head, the body and the legs. So again, just a quick test render. And by default the Maya Material X is fairly reflective, and I've left it that way simply so you can see that it's been successful. So now we've got these three materials applied, head, body and legs. First thing I want to show you is applying the displacement material and applying the normal map, and we'll do this before we add any of the color maps or the spec maps, simply so we can see what effect those maps have had from when we generated them in ZBrush. So I'll be back in the next part when we'll complete this tutorial and go over all the maps for the creature. Okay, so thank you for watching, and I'll see you in the next part. Hi, welcome back. In the last part we left off here, and we're going to continue now with applying some of the maps that were generated in ZBrush to our creature. Now we have our basic light and basic sort of reflecting background. Okay, so first things, before I do anything else, I just want to name these materials that we've created. So pop open your Hypershade, and if you want to see which material is assigned to which, you can simply select it and say select objects with material, and I can see this one is obviously the head. So in order for us to stop doing this every time we go around, I'm just going to call this creature head, and then I'll work out what this one is. So let's select objects with material, it's the legs. When you're dealing with a few maps and a few different materials, it's always good to keep up with the naming of your materials, otherwise you'll end up in a large mess. Creature body, and now we can just delete the materials we're not actually using, because I'm not using this reflective chrome we created, so I could just delete it once here, or an easier way is delete unused nodes, which will get rid of anything that's not currently in use in the scene. Very handy tip for cleaning up the Hypershade. Now I'm going to apply first the normal map so we can see what that does for us. So let's apply it to the head, and you can apply your normal map under the bump section of this mirror material. So I'm going to use the overall bump, and I'm just going to select this as file texture, and I'll just add the texture first, and here we have the maps that Jay has done for us, and unfortunately he's used the naming convention I'm not particularly familiar with. So we are currently doing the legs, I believe. Let's just make sure that we are. No, the body. So I'm going to need to just change that to the body normal map. My apologies. And there it is. Okay, so let's just go and apply the normal maps to the rest. They're not actually going to work at the moment, and I'll correct that. If you look at this bump 2D node that we have here, and I'll just graph that so we can make sure that's connected to the creature body, you'll set it to use as bump. Now because we're not using a bump map, we're using a normals map, you'll need to set this to tangent space normals. Okay, so make sure that you do this, otherwise it will not work. So let's do the creature head. So again, overall bump, file, and let's just make this the head. See where it is, must be this one. Okay, graph it. This will give us the bump 2D node, and we can make sure that that is then on tangent space normals again, and the legs. Get the file node and just grab the legs here. Okay, so we have a render that we've kind of tested out here, so I'm just going to save that one, and I'll do another render so you can see the impact that this normal map has had for us. Okay, and as you can see, we've got all of the nice bump that we should have, but something has gone drastically wrong on these legs, so let's go and debug that. So back to the Hypershade once again, and let's grab the creature legs here, graph the network. Let's look at the bump 2D, and it's set a bump value of 1, that's correct, and make sure it's actually using the right normal map. So this is the normal map for the legs, and that is, yep, so it is using the correct normal map. So let's look at the material itself. Okay, bump 2D. Okay, so something has gone wrong here. We've got users type bump. Now that's exactly what I said you should try and avoid, and I've done myself. As you can see, this bump is very nice when it's on a tangent space normal, and when we just leave it as a bump you get this, which is obviously not what we wanted. So again, it's quite easy to forget, as I just did, but make sure if you see some strange things like this, one of the first things to check is this. So now let's just quickly re-render. Okay, and as you can see with the tangent space normal set correctly, it works perfectly. Now the reason I'm doing this without colour and with this shiny reflective material is because it just makes it easier to see the effect that this normal map has before we go ahead and put any colour on, and I'm going to do the same now for the displacement. So let's go in and add the displacement. Now to add displacement we want to graph our network here in the hypershade, so that the creature body, I need to click on the shader and push this button, input and output connectors, to pop out its shading group. Displacements, pretty much all maps are added to the shader. Some special ones like displacement that's added to the whole shading group. So under displacement materials we want to click here and we want to select file and we want to give this a displacement. So we're currently working on the what are we currently working on? Excuse me, the creature body. So let's get the displacement body map, and I think we have it here. Okay, so here's the displacement map for the creature body. Now let's just flick that open. Now as we're using 16-bit displacement, the displacement will be entirely based upon the scale of the model. So if I was to scale this up by a factor of 10, I'd need to tweak the displacement values, and I'm going to show you that in a second. But let's just get all of the shaders done. So that's the body. Now let's do the head. So once again, have to pop out the shading group, file, give this the head displacement, which is here. Okay, and that's done. And now let's do the legs, graph network, once again, pop out its shading group, and displacement material, file, open, so legs. And there we go. Now I'm going to render this, and it's probably not going to work as you expect, but I just want to show you what difference the changes we make have before we push on. So let's save this with just the normal map. Okay, so this is rendered now with displacement, and a couple of things. The render time is shot up quite drastically from 19 seconds to 2 minutes 40, and you can see it hasn't really worked. All it's done is sort of poofed out our creature, hasn't given us much more in the way of detail, hasn't really done a lot for us at all except made it the wrong shape. Now in order to combat this, and also in order to combat the amount of time it takes, I'm going to use a mental ray displacement approximation. So if we select the body of our creature, and the approximation node goes on the actual geometry, so you don't need to select each individual shader. So you don't need to select the head, the body and the legs and apply an approximation node to each one. You just need one overall approximation node. So we go up to Window, Rendering Editors, there it is, Mental Ray Approximation Editor, and this gives us a couple of choices. You can use a subdivision approximation, which would be fine. You can use a displacement approximation as well. Now I'm going to use for this one just a simple subdivision approximation, so I'm going to hit Create. And you'll see here that I'm on panoramic. The number of end divisions I'm going to turn up slightly. The higher you turn this up, the better quality that you'll get, but for now that should be about fine. So let's just take another quick render of this, saving this one, and this should be a little bit faster. Okay, as you can see, this has now rendered in 35 seconds, and if we compare it to the last one, you can see it's actually added now a lot more displacement detail. So using a mental ray approximation node will allow you to render faster and actually render your displacements with a much greater degree of detail. So if we take a look at this now, and I'll just show you the difference between that and a displacement approximation. So let's take off our mental ray approximation node. So we can do this by going to the approximation editor, and you can see we've got a subdivision here, so I'll delete that and I'll create instead a displacement approximation, because obviously you've gone through a lot of trouble with this, creating the displacement maps for this in ZBrush, so you need them to look right. So let's do a U and V divisions of 3, and we'll render this and see where this gets us. Okay, so with the displacement approximation, as applied just now, you can see that we're not getting the displacement effect that we were getting with the, let's just have a look. So we were not getting the displacement effect we were getting with the subdivision approximation. So you're going to need to work out what works best for you. I would say the displacement approximation will give you a finer, more subtle displacement effect. It'll also show more fine detail than maybe a subdivision would. So again, it's all balanced really. One's going to take longer. One's going to take longer than the other, so it's a question of how much quality you need in the final render and how much fine detail you actually have in that displacement map. Now, another thing I talked about was, this is all dependent on the scale of your creature. So if I scaled this beastie up to 4 times the size, you'd no longer be seeing the displacement. It's just the nature of a 16-bit displacement map. So I can demonstrate this to you now. If we take a look quickly at our final render, you'll see you don't really see that much displacement. If I go into the hypershade and start to tweak the displacement on these, so you'll need to graph that out and then graph out the shader shading group, and then you'll be able to see the displacement node. It also appears here. So if we look under the displacement shader and we look under its file node and we go into color balance, you'll see here that the alpha gain is set to 1 and the alpha offset is set to 0. Now, for this to work properly, these settings are wrong at the moment. So in our case, the alpha offset should be half of this minused. So an alpha gain of 1 should lead to an alpha offset of minus 0.5. An alpha gain of 2 would lead to an alpha offset of minus 1, and so on and so forth. So let's just collect this for a start. So let's just make these all minus 0.5. Okay, and I'll show you how this solves one of the problems that we've been having, which is simply, regardless of what sort of approximation node we use, we get this kind of unnatural swelling on the creature that we simply do not want. See, its legs get chunkier, its mouth closes up, it's just its eye closes over, and this is not at all what we want. So I'm going to go back to the approximation editor, and I'm going to delete the displacement approximation because it takes longer to render, and I'm going to recreate the subdivision approximation. I'm just going to put that once again to 2.5. Basically, I'm just trying to give you as many options as possible. Now, when we render this time, you won't see this unnatural swelling. Okay, so now have a look between the two. Now we've got our displacement, but also we've got rid of that unnatural swell, and that's because Mental Ray needs to be told where the grey level of these is, and ours is always going to be half of what this is minused. So I'm just going to show you an over-exaggerated displacement now for, let's say, if we had a creature that was twice as large as the one we have now. Again, it's all dependent on scale. We need to set this to 2 or maybe even 4. I'm not ever going to go this high with this size scale of creature, but just for exaggeration purposes, and this needs to be minus half of that, so minus 2 in this case. Let's just change all of the displacements. Okay, and double check those, and I'm going to quickly render again, and I'm doing this so hopefully you guys won't have to. And obviously I know what's going to happen here. We're going to get a massively exaggerated displacement. I just want to physically show you what happens, simply because, you know, displacement is not the easiest concept to wrap your brain around every time. So sometimes, you know, a visual, here's what happens, is good in my opinion. Now you can already see before we finish this that our displacement is hugely over exaggerated. Now if you're looking for this type of displacement, then by all means use it, but I think in our case a sort of alpha gain of 2, which would mean the alpha offset being minus 1, would be about perfect. So, but again, I wanted to also show you that because this is always set to half minus this, so half this and then put a minus in front, basically, easiest way to do it, we still, even with this massively exaggerated displacement, do not have that unnatural swelling in it. And I see this quite a lot online. People grab a displacement map, they put it on, and the whole shape of the object changes. That's not what we're looking for. We're looking for that just the displacement details would obviously change. So let's jump in here and put the displacement at 2 and -1. Now, depending on how you've generated your displacement map in ZBrush, you might need to tweak that. I'm simply trying to give you enough information so when you've got your own displacement map, you'll pretty much be able to tweak the relationship between these two. It's not that complicated. Okay, and before we render again, let's just throw on a quick color map onto everything. So let's take the creature body and put a color map into its diffuse. So the color maps should be about here, and body. Okay, done that one, and we'll take now the creature head and just throw the color map on here. And Jay's used a naming convention I'm not familiar with here, but I would assume that when it comes for you to do this, you'll know what you've called your own files. Okay, there we go. And this was the creature legs, I think. Yes, it was. Okay, so now we've got a basic color map on all these, and we've set our displacement to approximately the right color, approximately the right settings, so it'll be a little bit more displaced than this and a little bit less displaced than this. Let's just bang a basic render with the color maps on. Okay, there we go. So you can see our color maps are on, and obviously this is way too shiny. It looks like we, sort of painted him in gloss paint at the moment. So the next thing we'll do is correct that. So of course we need to open up the hypershade and go into the materials. Now you see the reflectivity here is set at 6.6, which is extremely high. I'm actually going to set it higher, which sounds counterintuitive, but there's method to my madness. I'm going to set the glossiness down to 0.25. Now this is how sort of smudged those reflections will be, and of course because Maya material is a physically accurate material, it doesn't have a section for specularity. So we're going to use the reflection as the specularity, which is actually what true specularity is. It's the reflection of visible lights in the scene. So the reason I've set this reflectivity as 1 is because I don't really like to tweak this too much. What I prefer to do is go down to the BRDF and tweak the 0 and 90 degree reflection. So at the moment the 90 degree reflection is at 1, and because this is at 1, I know that that's a true 1. So this becomes much simpler than working out kind of what 1 of 0.6 actually means. So that's why I leave the reflectivity at 1 and change the BRDF, because then I have more control. I have the 0 degree reflection, which in our case should be tiny, so 0.01 maybe a little larger, 0.05, and the 90 degree reflection, which can come down to say 0.6. let's start with. I'm going to leave the BRDF curve at its default, and I'm going to change all of my materials to the same. So we use 0.05 and 0.6. And once again 0.05 and 0.6. Now I'll also need to change the reflectivity on both of those other materials to 1 and the glossiness to 0.25. And again, experiment with that. You might want a sharper specular highlight, in which case you can play around with the glossiness. And I'll also show you where to put your spec map in a second. But let's just see what we get now. Should hopefully not look like it's been painted with this high gloss varnish. Okay, so that's sorted out the high gloss look, and these little speckles you get in here is simply because my final gathering quality is not high enough, but I won't turn it up until a final render, because with these tests obviously I don't really want to be waiting more than a minute for a test render. So we've got it off the glossiness. You can start to see some speck coming through here, but it's not very pronounced, so we can fix that by changing the BRDF curve. Maybe this 0 degree reflection is probably a little too small. But before I do that, I just want to plug in the specular color now, which will go into the reflection color, or you could add it directly to the reflectivity here, which is what I'm going to do. So let's just graph the material, and rather than talk you through it, I can just show you. So let's take the creature body for a start, and let's come in here, and what we're going to do is graph a material to this reflectivity. So let's do that by adding our spec map in here. Okay, and these are our spec maps, I believe, and I need the body. Okay, that should be good. Yeah, just checking that I've got everything here. Right, that's fine. Okay, no, these are the spec maps, of course. Sorry, I've gone a little blind. So let's get the body spec in there. Open. Okay, and I'm going to show you why this is not really going to work. So let's just kidnap this and hit render. Okay, as you can see, that had pretty much no impact on this at all. If I flick between the renders now, you can see we just didn't really make any form of difference there whatsoever. So I've seen a lot of people do this, and it's not always the worst way to do it, but instead of putting your spec map into the reflectivity, I want to put it into the reflectivity color. Now I'm going to show you this as well, because it's also not going to work. So if I just drag my file 10 here, which actually let's just make another one to avoid any confusion, and let's get the body spec. There we go. And let's just map this up so we can see its connection. Okay, so we got the file node 11, which is the spec map, and it's now going into the reflection color. So now I'm going to render again, and I'll show you that this one doesn't really work either. And the reason why I'm showing you these things don't work is so you can avoid these mistakes yourself. Hopefully save you a little time. Okay, so that render finished, and you're looking at this and thinking it didn't work as I said it wouldn't, and you might be wondering why I've decided to show you a bunch of things that don't work. And it's quite simply, it's the most common problem a lot of people have, especially in later versions of Maya, because they've changed the way this works slightly, is that first they stick the spec map into the reflectivity and it doesn't work, and then of course they think okay, and they put it into the color and that doesn't work either. So what do you do then if you can't put it in either? You know, how do you use the spec map you went to all the trouble of creating? Well, the trick is you do put it into the reflectivity, but you can't just throw it in there. If you do that, it won't work. So what I'm going to show you now is how to do it. So what you'll need here, and let's just graph this again. So you'll see I've gone under data conversions, under materials here. So what I need to do is just separate this. This is our spec map, which was previously plugged into the color, and I'm going to plug it in to the reflectivity, but we know that won't work. So what I need to do is run it through another node first, and in this case I'm going to use an MIB color intensity for a variety of reasons. So I'm just going to drag this in here and go other, and I'm going to connect the out color here to the input of the color intensity node, and you'll see that change there. And then I'm going to connect this to the reflectivity, but because reflectivity is expecting one value and this is going to output an R, G and a B, I'm going to go other, I'm going to go out value R, and I'm going to connect that to the reflectivity. This will now work as a spec map. If I turn this spec map up to an insanely high value, so the whole thing goes white, just for our render purposes, just for our testing purposes, you'll see here that this now works. And I'm sorry to take you through those ways that don't work. They're just the most common ways most people try, especially with the changes in Maya 2014, and it's just not going to work for you, and I thought I would demonstrate that. But this is the way, or at least one of the ways you can do it. Okay, so as you can see, we've now gone back from this map to where we were before. Now I've cranked the input factor on that up massively, so it was all white, just to show you that it was having an effect across the entire body. But let's put that down and just modify our other shaders a little bit. So let's go for the head now, and once again I'm going to need to add in a file here. So let's go here. This will be our spec map, and this would be the head I believe we're working on, head spec. There we go. But we now know, let's just graph this, get it more back in order. We now know if we just leave this file here connected to the reflectivity, it's simply not going to work. So I'm going to need to break that connection, add a color intensity. You could use something like a luminance, it's entirely up to you. I'm going to add this other, so out color to input, and I'm going to throw this over here, other again, out value R to reflectivity. This gives the reflectivity one value to work with that it understands. Okay, so now our reflectivity on the head is done. Let's just do the legs. So once again, we're going to go to reflectivity, file. I'm going to add in here the leg spec. There we go. And let's graph this again to get it to less of a mess. Disconnect, because once again it's simply not going to work. And I'm going to take the color intensity, crank this over, and other, and out color input, and other, out value R to reflectivity. Okay, so I'm going to leave all the input factors at 1. You could actually tweak those. It's quite the reason I use the color intensity to do this and then split it out just on the red channel is because I can then use this factor to either lighten up my spec map or darken it up overall, in case, you know, I've made a spec map that's not quite bright enough. Maybe I don't have to go and regenerate it. It's just a handy little node to stick in there so you can separate out this R channel, the red channel. Okay, so now I've got the spec map done for all of my dinosaur, and I got to say that it's not quite shiny enough, so let's go and try its BRDF curve. Let's put this up to maybe 0.8, and let's try this at 0.1. This is something that you'll need to play about with because obviously this is a true reflective spec now. It's not a faked specular highlight, so again this will depend on what's in your scene. It's one of those artistic judgments you'll just have to make depending on what look you're going for. Okay, and I believe I set these to 0.8. So let's take a look at what our yon beastie looks like. Now it's got its spec map applied and we've tweaked its reflection a bit. Okay, I'm getting a little bit of reflectivity here, but not quite as much as I'd like, so I'm just going to make sure that that's all plugged in correctly, and I might get a little more glossy samples. This is what's responsible for some of this speckling, so let's go to 16 glossy samples. And again, now it's just a case of dialing up the BRDF curve until you get the sort of spec that you're looking for. So let's go once again and just dial this up. A little bit. I mean, this can really take quite a bit of tweaking. I might have the glossiness a bit low, So again, you're going to have to do some test renders to figure out the sort of skin type that you're looking for. Okay, and there we go. So if we look at the previous one and compared to this one, you can see we start to get more of these spec highlights, more overall reflectivity, as you'd expect to see on a slightly shiny skin. Depending on what look you're going for, you can now crank up your render quality and render away, which of course, by which I mean your final gather quality and your anti-aliasing and whatnot. Now I just wanted to cover this quickly, and I'm going to leave the teeth and the horn as an exercise for you guys. Just wanted to really show you how I designed the shaders and a couple of the pitfalls, which would be trying to use the spec map just by plugging it into reflectivity or color on its own is not going to work too well, and I wanted to go over how we did the bump map for tangent space normals, and of course how we applied the displacement map and how we changed the scale of it here. So this is really just a quick part intended to give you a look at how we design the shaders in Maya for all the textures that you've spent so long creating in ZBrush. So I hope you found that helpful. Any questions, you can find me or Jay on the forum, or you can email me directly at david@SimplyMaya. I'll be happy to answer any questions you might have. So thank you very much for watching this tutorial. I hope you got what you want out of it, and if you look at one of the final shots we did, if you want to or are interested in designing forestry scenes like this, please remember to check out the environment tutorial on the site. It's called Realistic Environments. So thank you again for watching. Goodbye.